November 1942, Richmond, California. A massive 10,000-ton cargo vessel, the SS Robert E. Peary, slides down the slipway and hits the water. Exactly 4 days, 15 hours, and 29 minutes earlier, this berth held nothing but empty space and a mountain of raw steel. By every known metric of maritime engineering, a discipline where a single ship traditionally requires months of painstaking labor by master craftsmen, this timeline isn't just unprecedented, it is mathematically and physically impossible. How did an American shipyard defy the laws of physics to achieve the impossible? The answer to that question is not a story of sudden industrial magic, nor is it proof that the Robert E. Peary was built under normal conditions. What happened at berth number 2 was a highly orchestrated, rigorously rehearsed demonstration of a brutal new philosophy of naval warfare. In the late autumn of 1942, the Atlantic Ocean was a graveyard. German U-boats were sinking Allied merchant tonnage faster than traditional shipyards could possibly replace it. To survive this battle of attrition, American industrialists realized they had to strip shipbuilding of its centuries-old traditions. They had to transform an elite, bespoke craft into a relentless, brute force assembly line, turning industrial speed into a weapon just as lethal as a torpedo. Yet behind this celebrated publicity triumph lies a complex historical reality, one that separates wartime propaganda from the actual mechanics of mass production. How did a labor force largely composed of absolute beginners, people who had never set foot in a shipyard before the war, execute such a massive engineering feat? And more importantly, what hidden, sometimes deadly price was paid when a nation chose to prioritize blinding manufacturing speed over traditional structural integrity? To understand why that terrifying price was considered an acceptable risk, the clock must be rolled back to the opening months of 1942. When the United States officially entered the conflict, the maritime reality was not just grim, it was mathematically fatal. By January, Admiral Karl Donitz had unleashed Operation Paukenschlag, Operation Drumbeat. German Type 7 and Type 9 U-boats crossed the ocean and arrived off the eastern seaboard of North America. They found a target-rich environment beyond their wildest expectations, coastal cities fully illuminated against the night sky, and merchant captains sailing alone, strictly adhering to peacetime shipping lanes without blackout protocols. The resulting slaughter was absolute. In the first half of that year, Axis submarines, mines, and aircraft annihilated over 4 million tons of Allied shipping. U-boats were sending cargo vessels to the bottom of the Atlantic at a staggering rate of 3, sometimes 4 a day. This was not just a naval defeat, it was an existential threat to the entire global war effort. Every strategic offensive drawn up in Washington and London depended on a vulnerable transatlantic conveyor belt. The Soviet Red Army, bleeding the Wehrmacht dry on the Eastern Front, desperately required American trucks, aviation fuel, and food to maintain its counteroffensives. The British Isles, functioning as an island fortress and the primary staging ground for any future invasion of Europe, required millions of tons of imported calories and raw materials simply to stave off starvation and maintain domestic industrial output. The United States could manufacture thousands of Sherman tanks in Detroit and roll millions of rounds of ammunition off the assembly lines in Ohio. But if those supplies ended up rusting at the bottom of the Florida Straits or sinking into the freezing depths of the North Atlantic, they were strategically irrelevant. The conflict was fundamentally a war of tonnage, and the Allies were bleeding out far faster than they could apply a tourniquet. The obvious, desperate answer was to build ships faster. But the reality of heavy naval architecture in the early 1940s made this physically impossible. For centuries, constructing an ocean-going vessel was treated as a bespoke, monumental craft. A shipyard would lay a massive steel keel on a single slipway. From that central spine, workers would slowly, methodically erect a ribcage of steel frames. Then, piece by heavy piece, raw steel plates were hoisted into place, precisely aligned, drilled, and permanently fastened. The critical bottleneck in this entire process was not just the availability of steel, it was the method of fastening itself. Ships were held together by millions of metal rivets. Riveting was not a job you could simply assign to a willing volunteer. It was an elite, physically demanding trade that required years of rigorous apprenticeship. A traditional riveting gang consisted of 4 men moving in perfect, dangerous synchronization. A heater who cooked the steel rivet in a coal forge until it was white hot. A catcher who caught the tossed, glowing rivet in a metal cone. A holder-on who braced a heavy bucking bar against the back of the rivet to keep it in place, and the riveter, who used a massive pneumatic hammer to smash the glowing metal flat, sealing the heavy steel plates together. A standard ocean-going cargo ship required well over 1,000,000 individual rivets. Driving them was deafening, exhausting, and inherently slow work. More critically, the United States simply did not possess enough master riveters to rapidly scale up production and replace the staggering merchant losses. You could not conscript a farmhand from Iowa, a schoolteacher from Boston, or a waitress from a diner, hand them a heavy pneumatic rivet gun, and expect a watertight hull. The national workforce for this specific skill could not be expanded overnight. Furthermore, the limited available pool of highly skilled maritime labor was already stretched to its absolute breaking point, building aircraft carriers, destroyers, and submarines for the fighting navy. The merchant marine was forced to compete for whatever scraps of labor, steel, and slipway space remained available. By the middle of 1942, the statistical reality sitting on the desks of the War Shipping Administration was stark and unforgiving. Analysts looked at the graphs tracking merchant tonnage sunk by the Axis versus tonnage successfully built by British and American yards. The lines on the charts were moving in opposite directions, diverging at a terrifying angle. German U-boats were sinking merchantmen drastically faster than the combined industrial might of the free world could launch them. This was not a theoretical problem for the distant future. It was a ticking countdown. At the current rate of mathematical attrition, the Allied merchant fleet would completely collapse before the end of 1943. If that happened, the Allies would not just lose the Battle of the Atlantic, they would lose the entire Second World War by default. The United States military would be stranded on its own continent, physically unable to deploy a single armored division or infantry regiment to Europe or the Pacific. The British economy would suffocate under blockade. The Soviet lines would inevitably shatter under the weight of logistical starvation. The crisis demanded an immediate, violent paradigm shift. Planners realized that simply optimizing the old system would never be enough. Shaving a few weeks off a standard 6-month construction schedule would not close the massive mathematical gap created by German torpedoes. If a single vessel required months of custom labor by master craftsmen on a dedicated slipway, the U-boats would win the war. To turn the tide, ensure the physical survival of the Allied nations, and move millions of troops across the oceans, the United States could not just build more shipyards. They needed to systematically dismantle, discard, and completely destroy the centuries-old definition of how a ship was built. The man who spearheaded this radical destruction was not an admiral, a naval architect, or a master shipwright. He was a pragmatic, aggressively ambitious American industrialist named Henry Kaiser. Before the war, Kaiser had built highways and orchestrated the massive construction of the Hoover Dam, but he possessed absolutely zero experience in building ocean-going vessels. To the conservative establishment of the maritime industry, this lack of pedigree was a glaring liability. To Kaiser, it was his greatest operational advantage. Because he did not respect centuries of maritime tradition, he was not bound by its limitations. When veteran shipbuilders looked at blueprints, they saw an organic structure that had to grow linearly from a central keel on a dedicated slipway. When Kaiser looked at the exact same blueprints, he saw a giant standardized steel puzzle. He argued that a cargo vessel was ultimately just a floating warehouse, and there was no logical reason it could not be manufactured with the same relentless logic as a Ford automobile or a household refrigerator. His first major heresy was discarding the heavy pneumatic rivet gun. Recognizing the severe national shortage of master riveters, Kaiser mandated a wholesale shift to a relatively new, controversial technique in heavy shipbuilding: electric arc welding. Conservative naval architects were deeply alarmed. They firmly believed that a rigid, fully welded hull would lack the inherent flexibility needed to withstand the immense torsional stresses of the open ocean. But welding possessed one supreme, undeniable advantage: it was incredibly fast. More importantly, the basic technique of fusing two pieces of steel could be taught to a willing novice in a matter of weeks, bypassing the years required for a traditional riveting apprenticeship. Kaiser then shattered the spatial limitations of the shipyard itself. Instead of bringing every single steel plate down to the berth to be assembled piece by heavy piece, he introduced the concept of extreme modular prefabrication. He divided the standard Liberty ship design into massive, distinct sections: entire deckhouses, bow assemblies, and watertight bulkheads. These sections were constructed simultaneously in vast staging areas scattered across the facility, far away from the water. In a bizarre defiance of gravity that shocked traditional shipwrights, entire multi-ton modules were deliberately assembled upside down on the factory floor, simply because it was physically easier and significantly faster for the welders to work facing downward. Once a module was complete, heavy cranes hoisted the enormous sections onto the main slipway, where they were rapidly fused together into a complete whole. The slipway was no longer a slow construction site, it was merely a final assembly point. This modular philosophy was radical, disruptive, and brilliantly efficient on paper. It promised to slash construction times from 6 months to mere weeks. But to actually execute this massive industrial choreography, Kaiser's sprawling assembly lines required an unprecedented amount of human capital. To physically outpace the mathematics of the German torpedoes, the shipyards needed a relentless, army-sized workforce, a workforce that, at the dawn of 1942, simply did not exist. Finding that massive workforce required an aggressive, unprecedented, and desperate recruitment campaign that completely ignored the entrenched social and demographic rules of early 20th century America. The millions of able-bodied working-class men who would typically perform heavy industrial labor had already been drafted into the Army and the Marine Corps, deployed overseas to fight on multiple fronts. The traditional maritime labor pool was completely dry. In response, Henry Kaiser's organization dispatched a small army of recruiters across the country, plastering railway stations, rural post offices, and town halls with colorful posters, promising extraordinarily high wages and a direct, patriotic role in defeating fascism. The result was a massive, chaotic, and completely uncoordinated demographic migration. Special chartered trains rolled into the coastal cities of Richmond, California, and Portland, Oregon, disgorging tens of thousands of civilians who had never seen the ocean, let alone the inside of a heavy industrial shipyard. They were sharecroppers escaping the poverty and segregation of the Jim Crow South, housewives from the agrarian Midwest, bank clerks, waitresses, and farmhands. The sheer influx of humanity was overwhelming. In a matter of mere months, the population of Richmond violently exploded from a quiet town of 20,000 to a sprawling metropolis of over 100,000 people, creating instant, overcrowded boomtowns entirely dedicated to the singular purpose of building ships. Housing was so scarce that workers lived in tent cities, slept in the back seats of their cars, or rented rooms where multiple people shared the same bed in rotating 8-hour shifts, perfectly mirroring the relentless, non-stop schedule of the shipyards themselves. But hiring this vast, wildly inexperienced civilian force created a profound and potentially fatal logistical problem. How do you build a 10,000-ton ocean-going cargo vessel with a workforce that does not know the first thing about naval architecture? Kaiser's answer was to ruthlessly deconstruct the elite craft of shipbuilding itself. He fundamentally removed the need for comprehensive knowledge. When a former waitress or a displaced agricultural worker walked through the gates of a Kaiser yard, they were not taught how to build a ship. They were taught how to perform exactly one highly repetitive specialized task. The traditional multi-year apprenticeship of a master shipwright was violently condensed into a brutal 2-week crash course in basic electric arc welding. A new recruit was handed a heavy protective fiberglass mask, a thick leather jacket and gloves to ward off raining sparks, and a heavy welding stinger, and they were taught how to strike an electric arc. They did not need to understand the complex hydrodynamic geometry of a steel hull, or how to read complex engineering blueprints, or how a ship absorbed the immense torsional stresses of a winter storm on the open ocean. They only needed to know how to fuse a specific 10-foot steel seam on a specific watertight bulkhead over and over again, hundreds of times a week, amidst deafening noise and blinding light. It was the ultimate, calculated de-skilling of a highly complex trade, transforming the bespoke, centuries-old art of maritime construction into a relentless, idiot-proof industrial loop, where human beings functioned as specialized cogs in a massive, steel-cutting machine. As this massive, heavily fragmented workforce was systematically slotted into Kaiser's sprawling, modular assembly lines, the very physical landscape of the American shipyard was violently transformed. The facilities on the West Coast did not resemble traditional maritime construction sites. They looked like sprawling, open-air automotive plants operating on a terrifyingly gargantuan scale. The production lines ran 24 hours a day, 7 days a week, divided into 3 punishing, non-stop shifts. At night, the shipyards were illuminated by towering banks of blinding floodlights and the harsh, stuttering blue flashes of 10,000 individual welding arcs, casting massive, chaotic shadows against the low-hanging coastal fog. Deep inside the facility, far away from the water's edge, endless trains delivered raw steel plates directly from the mills. These plates were immediately cut into precise shapes by automated oxyacetylene torches and fed into vast, deafening sub-assembly bays. There, teams of newly trained welders fused the raw steel into enormous, watertight bulkheads, double-bottom hull sections, and entire multi-deck superstructures. Instead of carrying individual pieces of metal down to the slipway to be riveted one by one, heavy flatbed rail cars transported these gigantic, prefabricated modules across the yard. Looming overhead, massive rotating whirly cranes, heavy-duty machines capable of lifting up to 60 tons of solid steel, would snatch these fully constructed blocks from the rail cars and swing them directly over the main slipways. Down below in the dry dock, heavily coordinated gangs of riggers, shipfitters, and welders would violently guide the massive steel blocks into place, locking them together like pieces of a gargantuan three-dimensional puzzle. As the civilian workers mastered their single, highly repetitive tasks, and the logistical flow of the prefabricated modules was continually optimized by efficiency experts, the production times began to compress at a terrifying rate. When the very first Liberty ship, the SS Patrick Henry, was built in late 1941, the process had taken 244 days, from the laying of the keel to the final launch. At the time, it was considered a respectable achievement, but it was a pace that guaranteed mathematical defeat in the Atlantic. But by the summer of 1942, as the brutal assembly line logic truly took hold of the workforce, that number began to plummet. It dropped to 150 days, then 100, then 60. The individual shipyards entered a state of frantic, hyper-competitive frenzy, with different shifts and different regions openly racing each other to launch hulls faster. By late autumn, the average construction time for a 10,000-ton Liberty ship across the entire Kaiser shipyard network had been ruthlessly hammered down to an astonishing average of just 40 days. A complex engineering process that had traditionally taken the better part of a year was now happening in little over a month. Hull after identical hull was sliding down the greased wooden slipways and crashing into the water in a relentless, mechanized rhythm, while the very next steel keel was already being lowered onto the slipway they had just vacated minutes before. Thousands of miles away from the roaring shipyards of California, in the heavily fortified headquarters of the German U-boat command in occupied Paris, Admiral Karl Dönitz and his senior intelligence officers were meticulously tracking the progress of the naval war. The German strategy was not based on capturing territory. It was entirely mathematical. It was based on calculating the exact monthly merchant tonnage they needed to sink in order to physically starve the British economy and permanently cripple the Allied war effort. As the autumn of 1942 approached, bizarre, seemingly impossible reports began filtering through German naval intelligence networks. Intercepted American radio broadcasts, analyzed by the B-Dienst codebreakers, and heavily monitored Allied press releases were openly, arrogantly bragging about American shipyards launching 10,000-ton freighters in under 50 days. In the sterile, smoke-filled map rooms of the German High Command, the veteran naval architects and tacticians of the Kriegsmarine reviewed these staggering numbers and openly laughed. To them, the American claims were not just slightly exaggerated, they were mathematically, scientifically, and physically impossible. Germany produced some of the most complex, heavily over-engineered, and technologically advanced warships on the planet. The construction of a single Type 7 German U-boat required many months of flawless precision engineering by highly educated master craftsmen working in established yards. The idea that a chaotic, newly constructed industrial facility in America, largely staffed by women, minorities, and untrained farm laborers, could produce a functional, ocean-going cargo vessel in 40 days violently contradicted every known principle of heavy engineering. German intelligence officially dismissed the reports as cheap, desperate American propaganda. They firmly assumed that Washington, terrified by the massive, unsustainable ship losses inflicted by the U-boats during the early months of the year, was simply fabricating construction records out of thin air to prevent a total collapse in domestic morale. But the reality of the American industrial miracle was about to violently collide with German arrogance on the freezing, contested waters of the North Atlantic. Out in the deep ocean, the veteran U-boat wolf packs prowling the established convoy routes peered through their attack periscopes, expecting to see the scattered, dwindling remnants of the Allied merchant marine. Instead, they found themselves staring at a bizarre, deeply unsettling phenomenon. The convoys they were hunting were not shrinking, they were rapidly swelling in size, and increasingly, the ships within those massive convoys all looked exactly the same. The silhouette appearing in the crosshairs of the German periscopes was unmistakable and utterly ubiquitous. A flush main deck, a single utilitarian exhaust funnel, and 3 tall, heavy cargo masts. It was the Liberty ship. They were not beautiful, graceful vessels. The Liberty ship was a blunt, unrefined, completely utilitarian instrument of war, devoid of any aesthetic grace, powered by a massive, completely obsolete triple-expansion steam engine. It lumbered through the ocean at a maximum speed of barely 11 knots, making it an incredibly easy, painfully slow target for a submerged, technologically superior U-boat. But what the Liberty ship lacked in speed, advanced technology, or beauty, it made up for in sheer, overwhelming volume. A single one of these ships could swallow a staggering amount of cargo, hundreds of Sherman tanks, thousands of military jeeps, or enough raw ammunition and high explosives to sustain an entire infantry division in combat. And suddenly, these identical, ugly steel boxes were everywhere, pouring out of the American shipyards in an endless stream and crossing the Atlantic in massive, heavily escorted columns that stretched to the horizon. Back in the German command centers in Paris and Berlin, the atmosphere of arrogant dismissal slowly metastasized into creeping, cold dread. Admiral Donitz's intelligence officers were forced to confront a terrifying new set of hard statistics that could no longer be dismissed as enemy propaganda. The U-boats were still highly lethal. They were still sinking hundreds of thousands of tons of shipping, executing brilliant torpedo attacks, and sending countless Liberty ships plunging into the abyssal depths of the ocean. But the total available Allied tonnage was no longer dropping. The lines on the strategic charts had definitively crossed. The horrifying realization finally set in among the German naval command. The American shipyards had actually done it.
A German U-boat was a masterclass in lethal, cutting-edge engineering, but it was a precision tool that took months to construct, required a highly trained crew, and carried a strictly limited supply of exactly 14 torpedoes. Once those 14 torpedoes were fired, the submarine was effectively useless and had to undertake a perilous, weeks-long journey back to a fortified concrete pen in France to reload. The American Liberty ship, by contrast, was a disposable, mass-produced commodity. For every 3 ships a German wolfpack managed to successfully hunt and send to the bottom, the sprawling assembly lines in the United States were launching 5 brand new ones to replace them. The German Navy was trying to fight a highly technical war of precision attrition, and they suddenly found themselves drowning in an unstoppable avalanche of raw American steel. The industrial conveyor belt was physically overwhelming the German torpedo supply. Through sheer brute force manufacturing and a total disregard for maritime tradition, the United States had successfully reversed the grim mathematics of the Atlantic War. The radical strategy of replacing master craftsmanship with blinding assembly line speed and modular electric welding was undeniably working, and the relentless flood of identical Liberty ships was keeping the Allied war effort alive, delivering the critical supplies needed to eventually crush the Axis powers. The industrial conveyor belt was definitively winning the global numbers game, turning logistical volume into a weapon that the U-boats simply could not counter. But the unforgiving, freezing environment of the North Atlantic Ocean was about to brutally expose the hidden, terrifying cost of Henry Kaiser's rushed industrial logic. The ocean was about to reveal a microscopic, fatal flaw hidden deep inside the hastily welded steel, a structural vulnerability that no one in the shipyards had predicted, and one that was about to rip the entire Triumph apart. The legendary 4-day assembly of the SS Robert E. Peary was heavily broadcasted in newsreels as the ultimate symbol of industrial victory.
But the event at berth number 2 was not a reflection of everyday shipyard reality. It was a meticulously rehearsed logistical stunt. Long before the keel was laid, massive components were pre-assembled and stockpiled just feet from the slipway to guarantee the record. This blinding focus on speed achieved its propaganda goals, but it effectively masked a terrifying vulnerability hidden within the core philosophy of mass production. By ruthlessly replacing master craftsmen with a vast army of newly trained novices, the shipyards had fundamentally altered the structural reality of the vessels. When a civilian recruit was rushed through a 2-week welding course, they learned to fuse metal but lacked the experience to recognize microscopic defects. Sloppy welds, trapped slag, and tiny invisible fractures became embedded inside the seams of the new hulls. Furthermore, the heavy prefabricated sections were often forced together on the slipways, locking severe internal stresses directly into the rigid steel framework. In the warm, calm waters of the California shipyards, these fully welded hulls held together seamlessly. But when those same ships sailed into the agonizing sub-zero environment of the North Atlantic winter, the physical properties of the steel violently changed. In late 1942 and early 1943, terrified reports began flooding the War Shipping Administration in Washington. Liberty ships were not just sinking from German torpedoes, they were spontaneously tearing themselves apart. Surviving crews reported a deafening crack, sounding like artillery fire, followed by a violent shudder. With zero warning, microscopic defects in the rushed welds would suddenly tear open. Fueled by freezing temperatures, a metallurgical phenomenon known as brittle fracture, a single tiny crack could propagate across solid steel plate at explosive speeds. Ships anchored in icy harbors or pushing through standard winter swells were literally snapping completely in half, their decks ripping open like paper. The absolute worst-case scenario had materialized. The frantic, modular welding technique that had resurrected the Allied logistics chain was now destroying it from the inside out. Extreme industrial speed had demanded a deadly structural price, and suddenly, the entire transatlantic supply bridge was balancing on the razor's edge of a catastrophic, self-inflicted collapse. The crisis crystallized on a freezing night in January 1943. Sitting perfectly still at an outfitting dock in Portland, Oregon, the newly launched SS Schenectady suddenly ripped completely in half with a deafening roar. The fracture tore through the solid steel deck and straight down the hull, causing the ship to violently jackknife into the water. This wasn't a torpedo strike in the deep ocean. This was a catastrophic structural failure in a calm, protected harbor. For the United States Maritime Commission, the disaster confirmed their absolute darkest fears. Their entire logistical lifeline was fundamentally compromised. Planners in Washington were trapped in an agonizing, high-stakes paradox. If they ordered the shipyards to halt the slipways, to properly train the civilian welders, and perfect the joints, production would plummet. The mathematical gap would instantly reopen, and the U-boats would win the war of attrition by default. But if they ignored the metallurgical failures and continued pushing raw speed, the Atlantic supply bridge would literally tear itself to pieces in the freezing winter swells. Millions of tons of critical cargo would be lost to the ocean without the Germans firing a single shot. They had to fix the crisis on the fly, without ever slowing down the relentless pace of the factories. Naval engineers scrambled for a parallel fix. They realized that because the hulls were continuously welded, a microscopic defect could propagate uninterrupted across the entire rigid vessel. They needed a mechanical tourniquet. The immediate, highly unorthodox answer was the installation of riveted crack arresters. Workers took cutting torches and deliberately sliced deep longitudinal slots directly into the steel decks and hulls of the ships, heavily riveting thick steel straps over the cuts. It was a crude, brute force compromise. If a brittle fracture initiated in the freezing Atlantic, it would tear through the steel only until it hit the riveted seam, where the physical gap would violently absorb the kinetic energy and stop the crack from completely severing the ship. Simultaneously, strict new welding sequences were enforced across the assembly lines. Foremen ordered their crews to weld from the center of the modules outward, physically pushing the locked-in thermal stresses toward the edges of the plates, rather than trapping them inside the hull. Critically, these sweeping structural changes were implemented without stopping the slipways for a single hour. Ships already loaded with vital cargo were hastily retrofitted at the docks just hours before joining the eastbound convoys. The industrial machine roared on,
balancing sheer manufacturing speed against the terrifying threat of sudden structural death. They had proven they could weld the ships faster than the enemy could sink them, but the true test was whether they could hold those fragile steel boxes together long enough to actually win the war. The desperate gamble of crack arresters and modified welding sequences ultimately held. The retrofitted hulls absorbed the punishing stresses of the winter swells just long enough to cross the ocean and unload their vital cargo. And the ultimate proof of this system's viability was the SS Robert E. Peary itself. The vessel, famously launched in 4 days at berth number 2, did not tear itself apart in the freezing Atlantic. It survived the Second World War entirely intact, operating as a fully functional freighter in both the European and Pacific theaters.
It proved that Henry Kaiser's hyper-accelerated assembly line was not just an elaborate publicity stunt. It was producing viable, structurally sound weapons of logistics. But the true strategic victory of the American shipbuilding program was never about launching one single hull in under 5 days. The Robert E. Peary was a highly orchestrated demonstration, a temporary concentration of manpower and prefabricated steel meant to push the modular philosophy to its absolute physical limit. The actual devastating blow to the German high command was the relentless, boring consistency that followed. By 1943, sprawling shipyards across the nation were no longer racing the clock for a single record. They were delivering 3 new cargo ships every single day without pause, regardless of weather or material shortages. Admiral Karl Donitz's U-boats were lethal, over-engineered masterpieces of naval warfare, but they were fundamentally artisanal weapons fighting an industrial algorithm. Germany had built a highly specialized military machine designed to win tactical engagements. The United States built a standardized logistical machine designed to win a war of mathematical attrition. Kaiser's controversial methods proved that raw industrial mobilization and rigid standardization could physically outproduce a sophisticated enemy's capacity to destroy. These vessels were never designed for longevity. They were expendable steel boxes given an official 5-year life expectancy, built for the singular purpose of overwhelming the enemy with sheer tonnage. Yet their historical legacy would ultimately extend far beyond the freezing battlegrounds of the North Atlantic. The Liberty ships were undeniably ugly, structurally flawed, and entirely expendable by design. Yet in their crude simplicity, they achieved a strategic victory that no elegant battleship could ever replicate. By stripping away centuries of aristocratic maritime tradition and replacing it with the brutal, unyielding logic of the factory floor, this fleet of identical steel boxes physically bridged the abyss. They transformed the deadliest ocean on Earth into a single, unbreakable American conveyor belt, relentlessly delivering the sheer mass of industrial power required to crush an empire.